Welcome to SS2 Chemistry, Term 2, Week 1. The atom is the fundamental building block of all matter. Our understanding of atomic structure has evolved dramatically, from Dalton's solid sphere in 1803, through Thomson's plum pudding, Rutherford's nuclear model, and Bohr's planetary model, to the modern quantum mechanical model. By the end of this lesson, you will describe the evolution of atomic theory, define isotopes and explain their existence, calculate relative atomic mass from isotope data, and apply these concepts to WAEC examination problems. Let us begin. John Dalton, 1803, proposed that all matter consists of indivisible atoms. Atoms of the same element are identical. Atoms combine in simple whole number ratios to form compounds. Dalton's model was a solid, indivisible sphere. J. Thomson, 1897, discovered the electron using cathode ray tubes. Electrons are negatively charged, much lighter than the atom, proposed the plum pudding model, a positively charged sphere with electrons embedded like plums. Ernest Rutherford, 1911, gold foil experiment, fired alpha particles at thin gold foil, most passed straight through, but a few were deflected at large angles, concluded that atoms are mostly empty space with a tiny, dense, positively charged nucleus. Niels Bohr, 1913, proposed electrons orbit the nucleus in fixed energy levels, shells, like planets around the Sun. Electrons can jump between levels by absorbing or emitting specific amounts of energy. Quanta explains atomic emission spectra. Modern quantum mechanical model, Schrödinger, Heisenberg, 1920s. Electrons occupy regions of space called orbitals, not fixed orbits, where there is a high probability of finding them. Key atomic numbers and symbols for WAEC: H, 1, He, 2, Li, 3, B, 4, B, 5, C, 6, N, 7, O, 8, F, 9, N, 10, N, 11, Mg, 12, Al, 13, C, 14, P, 15, S, 16, Cl, 17, Ar, 18, K, 19, Ca, 20. 3 subatomic particles: the proton, positive charge, +1, mass 1 atomic mass units, AMU, found in the nucleus; the neutron, no charge, 0, mass 1 AMU, found in the nucleus; the electron, negative charge, -1, mass January 1836 AMU, negligible, found in electron shells. Atomic number, Z, equals number of protons in the nucleus. This is what defines the element. Change the proton number and you have a different element. Mass number, A, equals number of protons plus number of neutrons. Number of neutrons equals A, Z. In a neutral atom, number of electrons equals number of protons equals Z. Notation: an element X with mass number A and atomic number Z is written as A over Z followed by X. Example: carbon, 12, is written as 12C with atomic number 6, 6 protons, 6 neutrons, 6 electrons. Electronic configuration: electrons fill shells in order. Shell 1, K shell maximum 2 electrons. Shell 2, L shell maximum 8 electrons. Shell 3, M shell maximum 18 electrons, but for the first 18 elements, it fills to 8 before moving to shell 4. Sodium, No, Z equals 11 configuration 2, 8, 1. Chlorine, Cl, Z equals 17 2, 8, 7. Calcium, Ca, Z equals 22, 8, 8, 2. Isotopes are atoms of the same element that have the same number of protons, same atomic number, but different numbers of neutrons, different mass numbers. Since isotopes have the same number of protons and electrons, they have the same chemical properties, they form the same chemical bonds and react in the same ways. However, isotopes have different physical properties, different masses, slightly different densities, different rates of diffusion. Examples of isotopes: carbon isotopes, carbon 12, 12C, 6p6n, 98.9% of natural carbon, carbon 13, 13C, 6p7n, 1.1%, carbon 14, 14C, 6p8n, trace amount, radioactive. Uses of carbon-14, radiocarbon dating. Living organisms absorb atmospheric 14CO2 through photosynthesis. When they die, no new 14C is absorbed. The 14C decays at a known rate, a half-life 5,730 years. Measuring the ratio of 14C to 12C gives the age of organic material up to approximately 50,000 years old. Used to date ancient organic artifacts, fossils, and archaeological specimens. Chlorine isotopes. Chlorine 35Cl, 17P18N, 75% natural abundance. Chlorine 37Cl, 17P20N, 25%. Hydrogen isotopes. Protium 1H, 1P0N, 99.98%. Deuterium 2HOD, 1P1N, 0.02%. Tritium 3HOT, 1P2N, radioactive trace. Heavy water, D2O, contains deuterium instead of protium, used as a moderator in nuclear reactors. Relative atomic mass, AR, is the average mass of one atom of an element, relative to 1/12 of the mass of a carbon-12 atom. It is a dimensionless number. Formula: AR equals sum of fractional abundance times mass number for all isotopes. Worked example 1, chlorine has two isotopes, 35Cl, 75% abundance, and 37Cl, 25% abundance. Cl equals open parenthesis 75 divided by 100 times 35 close parenthesis plus open parenthesis 25 divided by 100 times 37 close parenthesis is equal to 26.25 plus 9.25 is equal to 35.5. This explains why the AR of chlorine in the periodic table is 35.5, not a whole number. Worked example 2, boron has two isotopes, 10B, 19.9% abundance, and 11B, 80.1% abundance. B equals open parenthesis 0.199 times 10 close parenthesis plus open parenthesis 0.801 times 11 close parenthesis is equal to 1.99 plus 8.811 is equal to 10.8 as approximately. Worked example 3, an element X has two isotopes. One isotope has mass number 64 and contributes 68.77% to the natural abundance. The other has mass number 66 and contributes 31.23%. Calculate AR, X. AR equals open parenthesis 0.6877 times 64 close parenthesis plus open parenthesis 0.3123 times 66 close parenthesis is equal to 44.01 plus 20.61 is equal to 64.62. This could be copper. AR is almost equal to 63.5, slight discrepancy due to rounding. Real copper has 4 isotopes. WAEC tip: in all AR calculations, show the formula, substitute values, and show working. This ANS process marks even if the final answer has a small arithmetic error. Key points: atomic theory evolved from Dalton, 1803, through Thomson, Rutherford, and Bohr to the modern quantum model. 3 subatomic particles: proton, positive, mass 1, nucleus, neutron, neutral, mass 1, nucleus, electron, negative, negligible mass, shells. Atomic number Z equals protons equals electrons, neutral atom. Mass number A equals protons plus neutrons. Isotopes: same element, same Z, different mass number, different number of neutrons, same chemical properties, different physical properties. Carbon isotopes: 12C, 13C, 14C, radiocarbon dating. Chlorine isotopes: 35Cl, 75%, and 37Cl, 25%, give AR equals 35.5. Relative atomic mass formula: AR equals sum of fractional abundance times mass number. WAEC chemistry regularly tests electronic configuration, isotope definitions, and AR calculations. All calculations must show full working for maximum marks.